you feel have a little conversation here, but you guys, like I said before, number one, Alan's got enough letters behind his name to be the most credible person in the room here. But also, too, he is a personal friend of mine, and hearing his passion, hearing his heart, hearing his work ethic is absolutely next level. So, Alan, if you want to jump on and say hi to these guys, that'd be awesome.
Hey guys, hope everybody's doing well tonight. Ashton, before we get started, let me say something to Brooke and to Chelsea real quick. I can relate to both Brooke and Chelsea and so many people that are joining us tonight. My oldest daughter is a cardiovascular nurse specialist at Texas at Dallas Children's Medical Center in downtown Dallas, and she's part of a team that usually typically operates on micro preemie infants who are very, very, very sick. And so, when you're talking about the stress and the emotional aspect of that job, I hear it almost daily from my daughter, and so I relate, and you guys have absolutely no idea how much I appreciate what y'all do, because I see what she does, and I'm amazed. I've actually seen a picture of her holding an infant's heart it couldn't be any bigger than a peanut. I mean, it was just so small, and so just incredible what our medical professionals do, and I love that. So anyway, thank you guys, because y'all make all the difference in the world.
Yeah,
So
absolutely. Absolutely. It's so true. I mean, listening to those stories is incredibly, incredibly impactful. And, Alan, as a scientist, and obviously we have a lot of doctors and nurses and medical professionals, and I think Chelsea even hit on this, like you can be a very skeptical person who needs
yeah.
research, who needs foundational knowledge to believe in something. And so why for you, with all of your experience, why do you believe in the Make Wellness BioPrecision peptides?
Well, Ashton, it's really based on. I mean, there were several factors there, and so my PhD dissertation has an entire section on it on peptides, and so I know a lot about peptides. However, what I didn't know a lot about was bioactive precision peptides, and so when I started talking with Justin and Truman and our leadership team, which by the way, they are phenomenal people, and truly care about each and every person that comes in our business. So I want to say that, just getting to know them, and of course I've known Justin for the last 5 years, and getting to know Truman, but just seeing their passion for helping, and I've been in this business for 33 years, and I've created a lot of products, a lot of products. And in 33 years, I've never had a single piece of new technology. And so when I started talking with these guys about joining the team, and we started talking about bioactive peptides, they're a lot different than therapeutic peptides. And of course, if you do your research on therapeutic peptides, the first thing you see is they're unstable. They have to be injected most of the time. Rarely has an oral delivery system been created for a therapeutic peptide that is somewhat viable and effective. And so, in all my research on peptides, being they were therapeutic peptides, I was very skeptical about bioactive peptides, because man, you hear this and you're thinking, okay, they're unstable. Well, then you start getting into the research and you find out, no, they're not unstable. And then you figure out that most of the therapeutic peptides that are out there have their derivative. They're a derivative of some type of bioactive peptide, or a fragment of some type of bioactive peptide. And so you start seeing the research. And so the skeptic in me says, okay, I got to prove them wrong. And I sought out and went to work to prove them wrong. And I'm just like, it's not going to work. Can't work. There's no way. It's too much research that says they're unstable. Well, therapeutic peptides are very unstable. Therapeutic peptides have to be injected because they cannot withstand the different environments throughout the digestive system. However, bioactive peptides are created with intuitive systems that actually protect them from being broken down through digestion. And so my skeptic actually turned me into a believer because I spent several weeks doing a deep dive on bioactive peptides. In all my peptide research, all of my PubMed studies were on therapeutic peptides or specific therapeutic peptides. That's what I knew. I did not know bioactive peptides. So I go and I type into PubMed bioactive peptides. And guess what? 5,700, 5,800 studies pop up on bioactive peptides. And I'm like, well, heck, this isn't new. They've been around, and come to find out, you go all the way back to 1973 for the first studies that started coming out with bioactive peptides. So I'm going back, from 1973 here, we're talking 50, 60 years now of research on bioactive precision peptides. And what I found out was bioactive peptides have been around forever. The problem was figuring out how to unlock those bioactive peptides in a manner that both protected them and concentrated them to a level to where we could get the physiological activity. Now, that's where the technology comes into play. And this is what I had to find out for myself. And this is meeting with Justin and Truman, and then several meetings with our manufacturers. Our manufacturers are technology companies. That's what they are. They're not bioactive peptide technology companies. They are manufacturing technology companies that have spent hundreds of millions of dollars in figuring out ways to create a bioactive precision peptide concentrate. I'll use that word, but a concentrate that is heavy enough of active bioactive peptides, protected, encrypted, so that they maintain their biological activity throughout the digestive system. And that's what makes these things unique. So, and I'll give you an example. We talked about FIT a while ago, right? So FIT is fava bean in the two primary peptides, which are encrypted in about 4,000 other peptides and proteins and protein fragments. Those two primary peptides are derived, and they are found in any type of fava bean protein. However, they're found in very, 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 very small concentrations so low that you typically will not get the physiological benefit of those specific peptides. However, with the hydrolysis process that they have created and built over the course of the last 10 years of their studies, we've concentrated enough to where we can focus those two bioactive peptides at a concentration high enough to get the physiological benefits of those peptides. That's where it starts to get really exciting. So I know that's a long answer to your question of how did I get here? But it took me a long time to get here. I will tell you. In fact, I think I was making Justin and Truman, I just kept coming up as question after question after question after question, and meeting after meeting after meeting. And I think they were getting tired of me, quite frankly. But today I think they're glad that I did what I did, because it gave me a fundamental base of knowledge that I can sit here and confidently speak to our bioactive peptides, and these things are legit. They're very effective.
Yeah, absolutely. And you talked about this a little bit, but can you touch more on how the bioactive peptides survive the digestion process and they effectively get through the gut and through the liver to and still be intact for your body to use?
So the bioactive precision peptides are intuitively built in nature with some protective mechanisms that protect the actual peptides themselves. So first and foremost, they are, and you'll hear me use this word, and the more you hear me teach, the more you hear me talk about it, you'll hear me use the word encrypted. And that is the word that explains how these peptides are protected. And I love the analogy that Brooke used when we were in Nashville last week. It's like the difference between this encryption technology is the difference between a therapeutic peptide being a Volkswagen trying to drive through a landmine versus having a Humvee, an armored vehicle trying to go through a landmine, right? I personally want to be protected in the Humvee, the armored vehicle, to protect. Well, that's the same thing that this encryption technology and these intuitive protective mechanisms. For example, if you look at one of our bioactive peptides, it actually has numerous proline amino acids put at various parts of the peptide, okay, in various very precise locations of that peptide. Well, proline actually prevents bonds from being broken. So it is a strengthening of, or it has a strengthening effect to the bioactive peptide to protect that specific sequence of amino acids. Okay. The other protective mechanism is what we call cleavage sites. Okay. So there are very specific amino acids that are more likely to be cleaved. One of those, for example, is histidine. So when you see histidine in a bioactive peptide, histidine is what we call a cleavage site. It's easily attacked by an enzyme or an acid of some type, hydrochloric acid in the gut, and it's easily cleaved away from the other segments of a protein fragment. So if you look at our bioactive peptides, our two primary peptides are two of more than 4,000 peptide sequences that are found in the fava bean concentrate, the fava bean extract that we use. Okay. Those 4,000, the other 4,000 can be considered, like Brooke was saying, casualties of war, so to speak. They go in and they act as an intuitive protective mechanism to protect the two primary active peptides. And those two primary active peptides is where we get our enhancement of muscle protein synthesis and our prevention of muscle protein breakdown, our anti-inflammatory benefits, our myostatin inhibition benefits, and so forth. So yes, so it's the encryption process. Now, how do we protect the encryption process? That ought to be the real question. And that goes back to the manufacturing process. So the manufacturing process has to take into consideration several factors. And this is what you really have to understand. And this is what, okay, so I've been in manufacturing of various products, dietary supplements, nutraceuticals, all the way to pharmaceuticals and RX drugs for over 33 years. That's been my life. I've developed products, but I've been the CEO of 4 different companies. And manufacturing is everything. Manufacturing is where I have lived, right? Not only product development, but manufacturing. And so I understand manufacturing and I understand how difficult manufacturing can be. And so if somebody else is going to go out and try to copy and duplicate our fit bioactive precision peptides, it's going to take them forever to figure out every single component that we have figured out over the last 10 years in building these peptides. Okay. So you've got to think about the environment, the temperature, the shear of the mixers, the pH of the composition, the actual proteolytic enzyme used. And there are numerous proteolytic enzymes. You use the wrong enzyme, it breaks away the entire peptide during the process. And so those things are all very, very critical components of the manufacturing process that have been figured out and worked out over the last 10 years of the development of our product.
Yeah, that's incredible. So one thing with the synthetic peptides, people have to cycle on and off of those. And then two, people, I just saw them asking in the chat, this is a great question that you could hit on while you're talking about this, is how you can take all of our products together and how that works. So do you have to cycle off of our products in the bioactive precision peptides like you do synthetic? And then can you take all of them together?
Yes, you can take them all together. First off, let's get that out of the way. And it's no problem because each one has a very specific mechanism of action that they support. Okay. So we're not doubling up or tripling up at any time of taking all 6 products. And that's going to be very important for everybody to understand, because we're going to end up having 50 or 60 or 70 products over the next, 3 to 5 years. I mean, we have a very, very aggressive product development. What you see now, the 6 that we have now, that's just what we're starting with. That's what we're launching with. I'm already in the process of developing more products. So we're going to be launching product after product after product, and bioactive peptides are going to be our foundation. So just understand that. Now, the question, if you, well, tell me where you want me to go with that, Aston, because
Yeah, if you need to cycle on and off of these,
well,
right?
yeah. So therapeutic peptides, when we're talking about the cycle effect of the therapeutic peptides, there's a feedback loop mechanism that most therapeutic peptides work off of, very similar to hormones and some of our neurotransmitters and some of the things that, antidepressants can have the same effect, but there's a feedback loop mechanism that you have to avoid and be very careful with when you're taking therapeutic peptides. And that's why, and what that essentially means is that when you're taking a therapeutic peptide, you're essentially replacing an endogenously produced peptide or hormone or some type of endogenously improved chemical inside our body. What endogenous means is internally produced, something that's produced by our own body, right? And so when you take something that replaces that, then your body automatically turns off the production of it, because the feedback loop is saying, I've got too much. All right. Now, with our peptides, we're not given an endogenous peptide or a copy of an internal peptide. We are giving something that is totally exogenous to the human body, that's totally external, that our bodies do not make on their own. And so there is no potential or no possibility for a feedback loop to come back and tell our bodies to stop producing that product. So that's the difference in why you would have to cycle on, cycle off. You want to, when you cycle off, you're telling your body, and you're lowering it, you're telling your body not to forget how to produce that product or that hormone or that peptide. Okay. In this particular case, our bodies don't naturally produce it. So there is no feedback loop.
Right. That makes perfect sense. So last question, and this has all been incredible, but what's the difference between a bioregulator and our bioactive precision peptides? And maybe tell some people what a bioregulator is as well as you explain this.
Well, yeah, and that's an interesting, and let me say something. I love bioregulators, and don't think for a second that that we're not looking at some bioregulators to be used along with our bioactive precision peptides in some future products, because that's exactly what we're doing. I love bioregulators. Bioregulators are very, very, very small peptides, usually 2 to 3 amino acids in length, whereas bioactive precision peptides can be up to 20 amino acids in length. Bioregulators are so small that they actually have the ability to enter into the cell, enter into the nucleus of the cell, and impact their message directly into DNA. That's different than what a bioactive precision peptide does, because they don't actually inflict their message directly onto DNA. Okay. So our messaging system works at an entirely different level within the body to basically optimize or enhance a specific mechanism of action, whereas a bioregulator actually imparts an epigenetic trigger into DNA specifically. That's the difference. Okay, so one of them triggers DNA, one of them works off a messaging system that's outside of our DNA.
Okay, that makes perfect sense. Wow. I mean, I just want to keep asking you questions and keep going. Who could listen to Alan all night long? You guys give it up for Alan in the chat. Alan, thank you so much for not only for your time